So it's a pleasure to be here, and the list of authors that I have up there on the title slide are really the group that at Nebraska that's doing the dry lot cow work, and Carla would be out in the Panhandle. I think Carla's here, and then Terry and myself would be in the eastern part of the state. So much different climates in those two areas, and then you'll hear from Jason Warner tomorrow, and Jason is the graduate student that's involved with our dry lot cow work, and he really has done a nice job. And he thinks he's going to try to finish up here in December, so he may or may not get that done. So I just want to, you take a look at this and how much research at Nebraska we've done on this kind of system, and I would call this an extensive system, where you basically build the cow herd and to forage as much as she can, get as much of her nutrient requirements out of the forage system. You manipulate calving and weaning. You manipulate calving so it fits close to that forage resource to meet her requirements. And then you manipulate weaning so that you can get body condition back on those cows, because body condition is important for reproductive performance. Heavy calves then go into the feedlot, but then light calves might be put in some kind of backgrounding situation, maybe back on grass, and then maybe finished in the fall and in the winter. And in this particular scenario, this system, you really pay close attention to cow size and milk production, right? Because those are the things that really have an impact on not only feed intake, but also on nutrient requirements. So then you get into a system that we'll focus on here today, and this is a much different system, but as you heard earlier, this is a system that folks are really taking a look at. And I'll tell you why, at least in my perspective from Nebraska, why we're taking a look at it, some of our producers are. But you take a look at this system, maybe 100% of those, or 100% of the time the cows are in the feedlot, or they might be in a feedlot, as Ken talked about, a feedlot cornstalk grazing combination. And in this particular situation, body condition should never be a challenge, right? I mean, you take the feed to her, and do you pay attention to cow size and milk production? Probably not as much as you would in the other system that we talked about, because you're taking the feed to her. And so this is a much different system. You might take a look at when you calve, right? Because maybe you don't want to calve in the mud or maybe in the heat. And we calve in July, and so we calve in the heat. But we wanted to avoid the mud, and there's another reason why we calve in July, and Jason will talk about that tomorrow. This is a much different system than what we're probably used to, but there's a lot of producers in Nebraska. I shouldn't say a lot, but there are producers in Nebraska that are looking at this kind of system. So what I'd like to maybe focus on is talk about the supply and the price of pasture. Price of pasture, steady increase. I'll show you a slide where they looked at conversion of cropland or pasture land to cropland here in a few minutes. But this, I got this out of the newspaper about a year and a half ago. About 55,000 acres in Nebraska between 2011 and 2012 converted from pasture land to cropland. Now I found that on the sports page. Now that's on Sunday morning. That's a credible source, okay? But it was from the Game and Parks, okay? And they were looking at wildlife habitat, and that's what they calculated based on NRCS and those kinds of things. But that's quite a few acres. Steady price of pasture. I'll show you a slide on that here in a few minutes. We have interest by some producers to establish or expand a cow-calf enterprise. Expand an existing cow herd with limited amount of pasture, okay? And so they're looking at the opportunity to build that around a different system. And then we have some producers that want to start a cow-calf enterprise, but they don't have any grass. And so you think about how that might happen. I said this is a challenge, but this is probably in Nebraska, probably one of the most underused feed resources that we have, is that we have an abundance of crop residues. Crop residue, mainly corn residue. And we did a survey, and it indicated about 25% of the corn residue is used or grazed in Nebraska, which is much lower than what we would think, right, Bill? I'm thinking out west. I mean, you think every acre of corn stalks is grazed, but as you move further east, there's more corn and less cows, and so we still have an abundance of crop residues available for some kind of production system. So this is a slide, you'll see this again tomorrow, but Wimberly and Wright 2013 published this to be Iowa, Nebraska, Minnesota, South Dakota, North Dakota, and this would be, the color indicates the number of pasture or forage acres converted to cropland acres, 1.3 million. And that's quite a few acres. And again, in Nebraska, between 2011 and 2012, about 58,000 acres in Nebraska alone converted, and they led the nation in conversion of pasture land, forage land to cropland. This is some work, and Ken talked about trying to lease grass in Nebraska. I mean, there's not a blade of grass that's not spoken for in Nebraska. And this would be a survey, and this is done by Bruce Johnson. And I started plotting this back in 1986. And so each year he sends out a survey to producers, and he gets a lot of different data, but one of the pieces of data that he collects is pasture rental rates. And as you can see, a steady increase in the cost of pasture in Nebraska. That's if you can find it. In fact, you know, even 2013, 2014, not a big jump in pasture rental rates. And this is in southeast Nebraska, and this is a cow-calf pair. So it's not on an AUM basis. So this would be a cow-calf pair, and so those cows weigh anywhere from 1,000 pounds probably up to 1,400 pounds. But it's interesting, you have a steady increase in pasture costs. That's if you, or rental rates, that's if you can find pasture. The interesting thing is that Clint indicated I've been in extension for 30 years, and that doesn't seem like that long. But what's interesting, when I first started extension, it was much cheaper to summer a cow in Nebraska than it was to winter her. I would say that's flipped now. It's a lot cheaper to winter a dry cow as compared to summer a lactating cow. And the reason why that is, and I'll show you here in a few minutes, is because of you can utilize crop residues and graze them. Okay? And so steady increase, and that's a steady increase in pasture lease rates, and that's if you can find pasture to lease in Nebraska. So I did this calculation, and so there was interest by producers, and so what I did here, this would be the pasture lease rate, okay, $40 up to $90, and I put $21 a month per cow to lease corn stalks. And so that would be about 70 cents a day, and you can probably lease quite a few corn stalks at 70 cents a day in Nebraska. But what I did in this calculation, I said cows weigh 1,200 pounds, graze May to October, 1.5 AUM, so that's a 1,200 pound cow with a 300 pound calf beside her. 1 AUM is about 702 pounds of dry matter. So therefore 1.58 AUMs is about 1,050 pounds of dry matter pasture. So I took pasture price divided by that dry matter for 1.5 AUMs, got price per pound, and took price per pound divided by 2,000, got price per ton on a 100% dry matter basis. And so it doesn't take you very long to see why folks might be interested in dry lot and cows, especially when you take a look at what that converts to in a cost per ton dry matter for a bale of hay. And so this is an interesting calculation. Again, when you take a look at it, you can probably rent enough stocks out there for 70 cents per head per day, and that would be how that converts to a dry matter basis on corn stalks. So here's what I'm going to talk about today. I'll talk about unit cost of production, and because I have a reproductive background as well as nutrition background, I want to tie those two things together. But percent calf crop weaned of females exposed, and then talk a little bit about how it interacts with weaning weight. Okay? Impact of when a calf is born during the calving season on performance and economics. Compare feeds on a per price per nutrient basis, and then compare some systems that we have some data on in Nebraska on unit cost of production. So that's how we'll go here over about the next 30 minutes. And this is an important calculation for any cow-calf enterprise. I don't care if you're a conventional cow-calf enterprise or some kind of alternative cow-calf enterprise, but percent calf crop weaned or percent calves weaned of exposed is an important number, okay? It's not an economic number, it's a production number, but it ties into the economics, and I'll show you that here in a few minutes. But the idea here is that the number of calves weaned divided by the number of cows exposed to produce those calves times 100. Sometimes we make a mistake of putting pregnancy number divided by percent wean, or number of calves weaned to get that calculation, but that's not right. Okay, it's cows exposed, number of calves weaned per cow exposed. Okay, and that's an important number. Postpartum interval is important to manage in a cow-calf enterprise. Days from calving to first estrus. Cow herd efficiency. To get a cow to produce a calf every 365 days, right? She's got to be bred by 80 to 85 days after calving, if gestation is 283 days. An important number. And so pay attention to how you might manage postpartum interval. In most cases, you manage postpartum interval by managing cow body condition, okay? Because cow body condition is related to reproductive performance. Calving distribution, I'll show you some data here in a few minutes. How important is calving distribution? The number of cows that you get to calve during the first 21 days as compared to the second 21 days and the third 21 days. We've monitored that data up to about weaning, but I have a nice data set to show you where we monitored those calves born the first 21 days, second 21 days, 21 days, all the way to harvest. And we'll take a look at that data here in a few minutes. Now, you take a look at it, postpartum interval and calving distribution are related, right? And so you've got to manage those kinds of things, I think. It doesn't depend on whether you're an alternative cow-calf enterprise or a regular cow-calf enterprise, if there's any difference. And then weaning weight, of course, fits into there. But those reproductive parameters do drive the economics in the cow-calf enterprise. All right. So I'm not an economist, and so some of the data that I'll show you will be cowboy economics, but that's probably good economics, isn't it? And so it'll be just a little bit different than what you saw, but unit cost of production is a set of relationships, right? Annual cow cost, and then in the denominator is calf weaning weight times percent weaned and exposed. And that'll get you to a break-even cost or unit cost of production. Now, I thought I'd just illustrate what I'm doing here. And so what I did here is I took annual cow cost of being $950, and I held calf weaning weight at 550 pounds. So what I did over here is I changed percent calf crop weaned and then looked at break even or unit cost of production. And as you can see very easily, right, if you hold weaning weight constant and you hold cow cost constant, what happens to unit cost production as you increase weaned and exposed? It goes down, doesn't it? Because in the numerator is cow cost, but in the denominator is percent calf crop in a decimal form times weaning weight, okay? So just wanted to show you here how some of these production parameters are intertwined with the economics in these cow-calf enterprises, okay? Does that make sense to everybody? Right? Should. Okay, and so where are most of the potential calves lost to wean? And this is the reason why you don't take pregnancy divided number of calves weaned divided by pregnancy, number of cows pregnant, because this data would say, and this is a big chunk of data, it's old data, but it says the greatest number of potential calves to wean is lost because those cows don't get pregnant during the breeding season, okay? And so you still have costs associated there, and that's the reason why it's number of calves weaned divided by the number of cows exposed to the bull to produce that calf crop, okay? All right, so here's some information about the impact of calving distribution on performance. And this would be steer calves, and this would be some work done by Frick Funston at our Goodmanson Sandhills laboratory. And so this would be steer calves born the first 21 days, or male calves. No steer calves are born, right? Male calves born the first 21 days, male calves born the second 21 days, male calves born the third 21 days. And so they followed them not only up through weaning, but they also followed them on through the feedlot phase, and then they collected carcass data. Well, nothing surprising here is that, right, they're older, right? They're born earlier in the calving season, and at weaning time they should be heavier, shouldn't they? Because they're older. But what's interesting is at the feedlot phase, at the end of the feedlot phase, those male calves born the first 21 days are still heavier than those born the second and the third 21 days. One would think, or at least I thought, that those calf weights would come together at that time, but they don't. And it's a pretty good number up here, right? It ends pretty high. Dry matter intake wasn't different between those three groups. Hot carcass weight was greater for those calves born the first 21 days compared to the second and the third 21 days. Yield grade was higher for those born the first 21 days compared to the second and the third. Maybe not a good attribute. Marbling score greater for those that calved the first 21 days compared to born the second and the third 21 days. Choice or greater, not statistically different, p-value 0.13, but numerically greater for those that calved born the first and second 21 days as compared to the third. US day modest or greater Those calves born the first 21 days compared to the second, third greater, and then they put an economic analysis on there. So those that were born the first 21 days basically generated more dollars as compared to those born the second and third. And so this is really a nice data set that basically pulls together reproduction and performance beyond weaning. And it's important, again, doesn't depend on what kind of cow-calf enterprise that you have. These kinds of things are important to manage. All right. So the next thing I'll talk about here, and this is the thing that I work with producers quite a bit with, is I don't work with a lot of feedlots, but I have cow-calf producers that are looking at expanding their cow-calf enterprise in a dry lot kind of a situation. And so we go through an exercise of pricing feeds on a per nutrient basis. This goes further than comparing feeds just on a ton or a pound basis. You basically compare feeds on a dollar or price per pound of nutrient or price per pound of crude protein. And the other thing that's important that they have difficulty doing is comparing feeds at different moisture content. So how would you compare corn silage to dry hay, right? One's at 85% dry matter, the other one's at 35% dry matter, and so we go through a calculation. And so this is the one that we use. We basically take price per ton or price per hundredweight divided by the amount of nutrients on a dry matter basis. Basically, it prices these feeds on a 100% dry matter basis. Doesn't take into consideration the cost of labor and delivery, and doesn't include shrink and those kinds of things on feed. But it sure enough gives you a nice comparison, and they're all at the same level of moisture, which is 100% dry matter. So this is just an example, okay? And so this would be silage. They're looking at silage as an energy source. Silage and corn as both energy sources. I price the silage in at $38 a ton, 70% TDN, 35% dry matter. Corn at $3.80 a bushel, 136 bucks a ton, TDN, and the dry matter. So dry matter here is 85% and 35% for the silage. So if you just go through the calculations, 2,000 times 0.35 gets you the amount of dry matter that you bought, and then take that times 0.7 gives you the amount of TDN that you bought. Basically take that TDN value and divide that into 38 bucks a ton, and so on a TDN basis, that energy source costs you about 7.8 cents per pound of TDN. You do the same kind of calculation for corn, 1,700 pounds of corn that you bought on dry matter basis, 90% TDN. Basically, this is the amount of TDN that you bought. Take 1,500 into $136 a ton, and that gives you the cost per pound of energy in this particular feed source. And so as I take a look at, and some of the economics that I'll show you here in a few minutes, as I work with producers, these are the kinds of calculations that I go through so that they at least get the opportunity to get the cheapest feed resources, especially from an energy standpoint, because the majority of that diet is going to be energy, that they can on their place, and that they can handle it and they can feed it. So this would be a list of feedstuffs that's available in Nebraska. I priced them at $3.50 a ton. I said distillers grains at either 100% the price of corn or 86% the price of corn. Synergy, which is a modified distillers grains gluten feed combination, I priced it at 100% the price of corn. $50, $100, $85 for grass hay, and then $35 a ton. These are the TDN values that I used. You might say, well, that's not quite the TDN value of corn, but in high forage diets, the TDN value of corn goes down, right? Because there's that negative. We got plenty of data that would say it's at least not 90% TDN. So here's those same feeds. And what I did here is I actually added some shrink into there, and then added some grinding costs in there, and that's what they calculated out on a price per ton of energy. And so here we've included not only price per ton of energy, but we've also in that calculation have included grinding costs, which we need to have for the hay, and then some shrink in there. And this really gives the producer a nice idea of how they can compare a number of feedstuffs that they might be considering to use in a dry lot cow diet, and they can basically rank them and see which ones that they can get their hands on. At least they can get their hands on these kinds of feeds. All right. So here's how this thing goes, and so here's the diets that we've used, and this would be the diets that we used in year one. So this would be at ARDC. So this would be eastern Nebraska kind of a setup. So higher temperatures, more humidity, but both the diet independent of where we were about 40% crop residue, that being either corn stalks or wheat straw, and the other component being either modified distillers grains or wet distillers grains. All the diets that you'll see my economics on are limit-fed diets, and so those diets are fairly high in protein and energy, but remember they're only being fed they're being fed at less than what the cows can eat, and so somewhere around 1.5, 1.6%, 1.8% of body weight dry matter basis. So TDN content, both scenarios about 80% TDN, about 19% crude protein, and we always, in that supplement, include ionophore. This would be in year 2, ARDC and the Panhandle. Used some silage in there because it was fairly economical to get silage into that diet. This would be the crude protein, and this would be the TDN, and those cows were fed in a limit-fed diet. All right, so here's what I did for my economic comparison. We've got 5 different scenarios here that I'll talk about. And so this would be Goodmanson Sandhills Laboratory June calving herd. Okay, so that would be the Sandhills in Nebraska, and that would be the June calving herd. We have quite a bit of data on that June calving herd. DH would be Dalby Hollick, which would be a southeast Nebraska herd, and they'd be March calving herd. And so this would be the conventional system, DH system, and this would be, I would call DH2 or DH3. And so in Dalby Hollick 3, during the summer, half of the grass was supplemented using a distiller's cornstalk combination. Okay, so half grazed, half distiller's cornstalk combination. So know the number of days grazed. This would be stock grazing days here, pounds of hay fed, hardly any hay. Well, I have no hay fed. I think over 5 years, I think we fed a total of 250 pounds of hay to that June calving herd in the Sandhills, Nebraska. Dalby Hollick 1, Dalby Hollick 2, cornstalk bales, basically in that combination that Dalby Hollick distiller's grains, and then we have weaning weight. These calves are a little bit older. If you notice, this adds up to more than 365, doesn't it? So this is on a year, but any time that the calf went to the cow on stalks, we accounted for the calf being on stalks as well. Okay, and so these calves these are actual weaning weights. They're not adjusted weaning weights, and so these calves are a little bit heavier because they're a little bit older at weaning as compared to these 2 groups right here. So that would be 3 of the systems, and so this would be the 4th and 5th system. And so we've gone through confinement cows for 3 years, and so here we have the pounds of baled fed per cow. This would be the distiller's grains in that system, and this would be weaning weight, and this would be the ones that were weaned at 205 days of age. This would be the semi-confinement cows, and so this would be stock grazing days. This would be then when they were fed in the feedlot or dry lot, they would be fed crop residues and distiller's grains, and this would be the weaning weight. They're older at the time of weaning as compared to this particular group here, but all those days are accounted for when they're on corn stalks together and being fed distiller's grains on corn stalks together. So here's the confinement system, July calving, confinement system, semi-confinement system, 6 to 7 months in the confinement, and then stock grazing for 5 to 6 months. 6 months is kind of pushing it, at least in Nebraska, isn't it? But lo and behold, the first year that we did it was last year, and we grazed for about 158 days, I think Jason will tell you tomorrow. And then assigned days when cows and calves were together on stalks, we assigned those days as well. So this is the economics that I used, and so basically used grass at $42 a pair per month. That's $1.40 a day. Corn stalk grazing at 50 cents per head per day. I think you can get corn stalks for 50 cents. Distiller's grains, this would be 2013 at $170 a ton, and that would be the price on a dry matter. That would be the price. Hay, baled, then labor and yardage. And so for each of the systems, we put yardage in there. 10 cents per head per day for cows in conventional systems. So that would be for checking windmills, checking fence, and putting out mineral. I think I said that. 20 cents per day for those cows that were in that Dalby Hollick 3, where we supplemented half the forage with distiller's grains and residue. And then 45 cents per head per day for cows in the dry lot system. So what did total cost for those 5 systems is right here. This would be the weaning weight, and this would be the unit cost of production, or break-even cost. So what's interesting is that the 100% confinement system is much higher in break-even as compared to the other 3 systems. What I think is pretty interesting is that the cornstalk grazing, the cornstalk grazing confinement system is very comparable to our Goodmanson Sandhills June calving system. And so when you get outside of the dry lot system and incorporate some crop residues in there, it makes that system extremely competitive with a lot of the grass systems that you might think about. So this would be the other system that we've taken a look at. So that was 2013, and so this would be 2014. If you remember, 2013 forage prices were still pretty high. Distillers grains was still pretty expensive. So this would be 2014. Put grass price there at $45 a pair per month as compared to $42. So left stock grazing the same. Distillers grains at $108 per ton as compared to $170 a ton. Hay and then cornstalk bales at $50 a ton. Again, we have the yardage in there, and then we have cow cost. And cow cost, I moved it up between 2013 and 2014. Basically, that includes bull cost, replacement cost, and that kind of thing would be in that number. And I think Harlan Ritchie would say that probably needs to be a little bit higher, but that's what I put in there for this particular analysis. Base the distillers grains on 86% the price of corn. And again, put yardage in there, a dime for cows in conventional systems, 20 cents per head per day for cows on the Dalbyholic 3 system, and then 45 cents per head per day for those cows that are in the dry lot system. And so this is what this looks like. Unit cost production 2014. So this would be total cost for each of the 5 systems. This would be the wean weight, and then this would be the break even. Because I used in this particular scenario about 85 or 85 to 88% weaned of exposed. And remember, I moved up cow cost about $75 to $100. Unit cost production went up because forage costs went down and distillers grains costs went down between 2013 and 2014. Confinement, 100% confinement cows, that unit cost production went down. But still, you take a look at the combination of confinement cows and putting them out to graze corn residue, that system is extremely competitive with any of the other grass systems that we'd have, at least in Nebraska. So what I did in this final slide here is I said, okay, what would you be able to pay for grass in these 3 systems to get the same break even as you would get in the total confinement system? Okay, does that make sense? So what could you pay for grass? That'd be a cow-calf pair per month, and that break-even would then equal $2.01, which is the highest cost system in this particular scenario. So if you're in the Goodmanson Sandhills laboratory system, it was our laboratory June calving system, $62.40 per pair per month. Dalbyholic system, $55.50, and then $66 for the Dalbyholic system, where we incorporated distillers grains and crop residue in there. All right. So in summary, this is what I hope to have you take home. Reproductive performance drives the economics of cow-calf enterprise, and really getting a handle on calves weaned to female exposed becomes pretty important. In the economic analysis, it's part of the denominator. Body condition at calving is a major impactor on pregnancy rate, but it should never be a problem in a dry lot system, should it? I mean, you take feed to them, so you should be able to manipulate body condition however you feel because you're taking all the feed and nutrients to them. Price potential feeds on a nutrient basis. Dry lining cows 365 days is expensive, at least in our calculations. But the interesting thing is it depends on what pasture prices do, don't they? That trend line continues to go up, and probably those unit cost production are probably going to come together. Combination of dry lotting cows and then grazing crop residues seems to be very competitive to other cow-calf systems. And Jason's going to give you more information on that, at least the Nebraska system that we've used here the past year. So with that, I'd be glad to take any questions. This is our beef website, beef.unl.edu. We have a number of beef reports that basically have that information that I presented here. And there'd be a lot of other information on the dry lot cow project that we have in Nebraska. Thanks a lot.
We have time for a few questions.
Good.
We have time for questions. One in the back.
When you had the amount of dry matter roughage and the dry matter distillers in your confinement situation, you had 1.5 more times dry matter distillers consumption versus roughage, but that just seemed a little odd. Okay, I'm not following your question. So those diets in the dry, in the confinement. Yeah, they were 60%, 60-40, right? Okay. You can just go into that back to that slide. Okay. And there's a big part of that. Right there. Oh. Or one right there. Yeah. So 106 pounds of dry matter versus 2738 pounds of dry matter. Am I reading that right? So what here? So this one. So these cows are only in the dry lot for 6 to 7 months. Yeah, I understand that. Okay. But that confinement one, you're showing feeding almost 1.5 more times of distillers grains versus baled stalks on a dry matter basis. Yeah. Yeah, it's too high. That number's wrong. Yeah. That's almost like 15 pounds of dry matter distiller grains on a daily basis. Yeah, would they be close to that, Carla? Yeah, they'd be pretty close to that. Yeah. At 60-40, they'd be really close to that. Yeah, that's okay. At 60-40, yeah, they'd be really close to that. So 15, yeah, that'd be about right. Yep. Go ahead, Steve.
How did your body condition scores compare among treatments at various stages of the production?
Yeah, not. It's interesting. Most of those cows remained in between a 5 and a 5.5 all the way through that system.
Was body condition then your primary determinant in terms of how much you fed the cows in confinement or semi-confinement?
We fed them a percent of body weight, whether they were lactating or gestating. And we found out it was pretty easy to keep body condition on cows in limit-fed diets, even during lactation. So I'd say during lactation, we had some. I would say the average is about 5.1. So we had some 4s and we had some cows with 5.5 to 6. But it was relatively easy to maintain body condition on those cows.
Comparable, in your opinion, among treatments?
Exactly. Yeah, they were. Yeah, the toughest thing is on a limit-fed diet is they get kind of ganted up on you a little bit, right? So they're kind of tough to look at. But from a nutrient standpoint, based on body condition score, we were doing an excellent job of meeting their requirements. Yeah. Go ahead.
Is that partially because you're creep feeding the calves?
We didn't creep feed the calves. We didn't, and that's part of the. I didn't present that data, but I think Jason, you probably presented that last year. But we didn't creep feed the calves. Is that when the calf was with the cow, we had about 3.5 to 4 foot of bunk space, and that allowed for the calf to come to the bunk as well. We made adjustments on cow. So there was an early weaned set of calves in the first 2 years, and then a set of calves that stayed with the cows. And so we would monitor the amount of feed. The calves that were early weaned were being fed the same diet that was in the bunk for the cows and the normal weaned calves. And so we take the amount that was fed, add that to the 15 pounds of dry matter for the dry cow, and that's the amount that we distributed in the bunk. So we didn't creep feed the calf. The calf was with the cow at all times. Yep.
How do you do that on a limit fed basis where you limit feeding the cow and the calf?
Yeah, it's tricky. And so really in that scenario, the calf comes to the bunk and eats, I'll tell you that. Now, did we accurately measure the amount of intake that the calf was eating when the pair were together? Probably not. But they eat. As long as you have plenty of bunk space, that calf will come to the bunk and eat. So that's not a challenge. The challenge is that the cows know that they're limit fed, and it can be pretty chaotic at the bunk if you don't have enough bunk space. The calf gets hurt, yeah, or can get hurt potentially. Go ahead.
In an old cow, broken mouth cow system where you're going to be shipping killer cows, wean the calf, ship the cow, are you able to limit feed cows in that system, or are you?
We've not done that system, okay, with broken mouth cows, yeah. But I don't see why you couldn't.
We've done that.
You've done it, but I don't see why you couldn't, because it's amazing to me how we were able to maintain body condition on a limit-fed diet. But that's a pretty energy-dense diet that I showed you there, 80% TDN. Yeah.
So you're limit feeding, but, so you have a gant cow like you're talking about.
Yeah.
She just doesn't have a big old belly.
That's exactly right.
She's in great.
She's in good shape. Yeah. Yeah. I should have brought some pictures. Go ahead.
Are you feeding once a day, twice a day, 3 times a day?
Yeah. I think to keep costs down, one is I think if you get into a dry lot cow deal, I think we're pretty convinced it has to be limit-fed diet. Okay? Because if not, the diet gets really bulky, and that means you got to take 2 passes at the bunk, and that's cost. And so we only fed once a day, and I think one of the things that you need to think about when you eat limit-fed diets, you feed at the same time every day. Okay? So once a day, and so they eat for about an hour, and they're done for the rest of the day. But they've adapted, they adapt fairly quickly. I've done that, we've done that with our cows, and I've done that with a set of research cows outside of this project, and it took them about 7 days to adapt. Yep. So 1 pass at the bunk, and we're pretty convinced that it has to be limit-fed because of the bulk of the diet that you have to take out there if it's not limit-fed. Yeah. Go ahead.
On your group that you turn out on corn stalks,
Yeah.
after the prolonged period of limit feeding them for 6 months, do you see function, their stomach's going to shrink, right? And then whenever they go out to stocks, are you supplementing them at all whenever they go to stocks?
So Jason,
Help compensate for that while they stretch back out again or not?
we don't. We basically, the idea was when they go to stocks, we want to have the same energy going into them as the cows that were left in the confinement. Okay, so we did supplement with distiller's grains. The range would be anywhere from 3 pounds up to 7 pounds for an average over that stock grazing period for about 5. But they adapt fairly quickly. I mean, those cows had been cornstalk grazing cows, so we don't have any heifers in the system. So they've been cornstalk grazing cows prior to when we got them. And so some of those cows have been in the dry lot now for 4 years. And so half of them still remain in the dry lot. The other half go out to corn stalks. There's no adaptation. I mean, they go right after it.
But you're still supplementing them.
We're supplementing them, but it's only because they're lactating.
Right.
It's only because they're lactating when we get the same energy density into those cows on stocks as those cows that were taken in the dry lot. Yeah. Go ahead.
Rick, do you rotate within the stocks, or do they just have an open field?
So there's reps. I think there's 2 reps at Panhandle, and we had 4 reps at ARDC. And so midway through, we moved to a fresh set of stocks. Yeah. Jason, is that correct? He says I'm good to go. I'll tell you who runs the program, right? He'll talk tomorrow, right? I just wanted to make sure that was right. But we have 4 reps, and so we do. Yeah, we do rotate some. Yeah,
Body condition?
He'll show you that tomorrow. Yeah, he'll show you that tomorrow. I don't want to take his story, but he'll do a nice job of summarizing that. Yep. So we do base our grazing on our recommendation of husk and leaf, and then leave half the husk and leaf. Okay. So there's 16 pounds of husk and leaf per bushel of corn, and so we make that calculation to get grazing days. Go ahead.
What would the stocking density per acre be on that grazing horse house?
Well, of course, we're working in small. I don't know if I can answer you that. So we would figure the number of days that a cow could graze a field based on husk and leaf in that field, and we can calculate husk and leaf based on yield. Okay, and so there could be a number of different grazing densities out there. I worked with a group that had a pivot, and they had 240 bushel corn and regrazed 400 cows for it's a 130 acre pivot for 20 some days. That's pretty intense. But then we'd have guys that have, or producers that have a pivot of corn and graze 40 cows for a lot longer. So there's a lot of different stocking density. Now I don't know, Jason will talk about stocking density tomorrow. Yeah. Go ahead, Steve.
How much difference Was there in days of age at weaning among the 5 groups, right?
So the 2 Dalby herds would have been 205, 205 days, about 205 days of age at weaning. So the semi-confinement calves are sure enough, Jason will tell you tomorrow more days. And then the Goodmanson GSL calves basically went to corn stalks with their pairs, and so they'd be older at weaning as well. So that GSL group that I compared, they had a weaning weight of 558 or something like that.
The weaning weight, if I'm hearing it correctly, would be much a function of days of weaning.
It is. It is. So the ones that are heavier are actually older. But how I accounted for those days in the feed allocation. So if a pair went to stocks together, I counted stock grazing days against the calf as well to get that on a level playing field. Okay.
I think we have time for one more question.
Al, go ahead.
So if I read your numbers right, you standardized your weaning percentages at 85%.
We did.
But I'm curious, so on the fed calves or partially fed or partially confinement calves, did you actually achieve a higher number of calves weaned per female exposed?
We just barely collected 1 year data on that.
Okay.
We're not, yeah, so I'll hold off on that. We need to have a few more days, a few more years of data on that. And I know Jason will talk about pregnancy rates tomorrow. Preg rates are really pretty good in these scenarios. So he'll talk about preg rate, but so we need a few more years to get good numbers on weaned of exposed.
Okay.
Yeah. I'd say that, I think as a general statement, I'd say it's not 90%. It's probably slightly lower than 90% in confinement cows. I shouldn't say slightly lower, but it's lower than 90% in confinement cows. We only have 2 years of that data.
Please join me in thanking Dr.